Okay, so in this video we're taking a look at a transformation of the tangent graph, and a lot of what we learned about the transformations of sine and cosine are going to apply to transformations of tangent. We're just going to modify things a little bit. Now over here in the right hand corner of the screen, I just graphed one period of tangent going from negative pi over 2 to pi over 2. I'm going to sort of use that to remember this is the thing that I'm transforming. And what I'm going to try to do here is I'm going to try to graph exactly 2 periods of this. So I want to do 2 periods, and I want to plot 3 points per period. Okay, now if I take a look at what I'm doing here, everything that I'm doing, multiplying by 2 and adding pi over 4, I'm doing that before I plug into tangent. With sine and cosine, we learned that if we modify things before we plug into the trig function, it affects things horizontally. So this is going to be a horizontal transformation. So what I'm going to do is I'm going to try to figure out for just one period, and then we can build a second one from that, where I should start and where I should end. So my standard period for tangent, this one's interesting because I don't want to start at 0, because the rule is you got to start and end at an asymptote. So I know that tangent does its thing exactly once, as the input, which in this case is 2 times x plus pi over 4, whoops, I'm sorry, as the input varies from negative pi over 2 to positive pi over 2. So I'm going to solve for x, and that's going to give me a new starting and ending point for one period of the tangent graph. So I'm going to divide both sides by 2. Let's remember that that's equivalent to multiplying by 1/2. So this is going to become negative pi over 4 less than or equal to x plus pi over 4 less than or equal to pi over 4. And now I can subtract pi over 4 from each piece. And that's going to give me that negative 2 pi over 4 is less than or equal to x, which is less than or equal to 0. And so that's negative pi over 2 less than or equal to x less than or equal to 0. And actually with tangent, I apologize, these guys should have been strict inequalities. I'm going to fix that. Every one of these inequalities, I was subtracting, should have been a strict inequality, because those endpoints were where we actually have the asymptotes. Now I could, in theory, stop the video camera and just reshoot the video, but I'm actually going to keep that mistake recorded because it's a learning opportunity. Learn from my mistake. Don't make it yourself. Let me do it. Okay, so I know when I'm graphing now, that gives me a starting and an ending point. Okay, so just like with sine and cosine, I'm going to figure out what the new period is. And I have, again, 2 ways of doing that. I can say it's my ending point 0 minus my starting point. So it's 0 minus negative pi over 2, which is pi over 2. Or I can say it's the old period divided by whatever number I was multiplying x by, which is 2. Just be careful. With sine and cosine, the old period was 2 pi. With tangent, it's pi. Notice either way I do it, I get the same thing. The new period is pi over 2. Okay. So now, if I want to plot a period like this, notice, even though I'm not plotting quadrantal angles, by plotting an asymptote at my starting point, and then a midpoint, a 0, a midpoint, 0, basically I'm still dividing this interval up into 4 pieces. They no longer correspond to quadrants, they correspond to half quadrants. But I can say, okay, so my new increment is going to be pi over 2 divided by 4, which means multiplying by 1/4. My new increment is pi over 8. So when I am plotting my points, I'm going to start at negative pi over 2. Now negative pi over 2, if I multiply by 1 in the form of 4/4, is negative 4 pi over 8. So I'm going to just mark off 1, 2, 3, 4. Each of those tick marks now is a pi over 8. So this is negative pi over 2, which is negative 4 pi over 8. then I'm going to add pi over 8 to that. So I'll get negative 3 pi over 8. Then this would be negative 2 pi over 8, but I'm going to reduce that to negative pi over 4. And this would be negative pi over 8, and then I'm at 0. Okay. So that takes the interval from negative pi over 2 to 0, and it neatly divides that up into 4 pieces. And so now I'm ready to plot things. At my starting point, I have an asymptote. At my next point, we were at negative 1. At my next point, we're at 0. At my next point, we're at 1, and then the next one is an asymptote. So this is going to climb up like so. I can make it curve a little bit better. There we go. So there's one period of this. Now I've plotted 1, 2, 3 points for that period. When you're labeling your points, you can either do what I've done, which is label the tick marks on the x-axis and the y-axis, or if you prefer, you could label them at the points. So I could have said this point is negative pi over 8, positive 1. So you can either label at the point as an ordered pair, or just clearly label both axes. Okay. So let's see, we wanted 2 periods, so I guess I have to keep going, but now I'm on a roll. I was just counting by pi over 8, so I'm going to have a pi over 8, 2 pi over 8, which will reduce to pi over 4, 3 pi over 8, 4 pi over 8, which will reduce to pi over 2. I can draw in my asymptote because I'm ending there, and then 0's in the middle. This point here was at a y value of negative 1. This point was at a y value of 1. And then I can connect the dots to have my beautiful tangent curve. It's just been compressed so that it's doing its thing over a shorter period of time. Okay. All right, next video we'll try some vertical transformations of cotangent.